Imagine the galaxies, stars, and planets all residing within your brain. Sounds far-fetched? Not really. Today, we're going to explore how the entire universe is, in fact, in your brain. Let's start by putting things into perspective. The vast expanse of the universe with its billions of galaxies may seem incomprehensibly large. But if we look closely, we see a striking resemblance between the cosmos and the complex structure of our brains. This idea, often referred to as the universe within, is an incredible concept that draws parallels between the cosmos and the human brain. You see, the human brain is a marvel of nature, an intricate network of billions of neurons, all working together to create our thoughts, memories, and consciousness. The exact number is a matter of scientific debate, but it's generally accepted that there are around 86 billion neurons in the average adult human brain. Each of these neurons can connect with thousands of others, forming an intricate web of connections that rivals the complexity of the universe itself. Now let's pivot to the cosmos. The universe, as far as we can tell, is home to around 100 billion galaxies, each one brimming with billions of stars. Just like the neurons in our brains, these galaxies are interconnected in a vast cosmic web. They cluster together, forming superclusters and cosmic filaments, much like how neurons form networks in our brains. So in a way, the structure of the universe mirrors the structure of our brains. The galaxies are like neurons, the stars like synapses, firing away, creating a cosmic symphony of light and energy. And within this cosmic symphony, we find ourselves tiny beings on a tiny planet, with the entire universe mirrored in our minds. In essence, the universe is not just out there, it's also in here, within us, within our brains. Just as there are billions of galaxies, there are billions of neurons firing away in your brain right now. Isn't that mind-blowing? Let's dive deeper into the universe within us, starting with the neuron's intricate network mirroring the cosmic web of galaxies. It's a startling concept, isn't it? That the vastness of the cosmos could be reflected in the minuscule confines of our brains. But the parallels are too striking to ignore. Consider this. The observable universe, a staggering 93 billion light-years across, is composed of galaxies strung together, forming an interconnected web. Now imagine shrinking this cosmic expanse into the confines of your brain, a mere 3 pounds of matter. Here we find another web, this one spun from neurons. The total length of these neurons? An estimated 100,000 miles. That's enough to circle the Earth 4 times over. Just as the universe is not a random scattering of galaxies, the brain is not a chaotic jumble of neurons. Both systems are node-based. In the universe, galaxies group together into clusters which are connected by cosmic filaments. Similarly, in the brain, neurons form intricate circuits, communicating through synapses. The universe, with its billions of galaxies, and the human brain, with its billions of neurons, are systems of such complexity that they are often described as networks. Both are characterized by the surprising regularity of their small world, scale-free network properties, and both exhibit the property of clustering, with a tendency for linked nodes to also be connected to each other. In the cosmic web, galaxies are the nodes, linked by gravity. In the brain, neurons are the nodes, linked by synapses. The similarities are astounding, aren't they? A web of galaxies, a web of neurons, each a universe in its own right, each a complex network of connections and pathways. Despite the vast difference in scale, these two systems share a striking resemblance. It's almost as if the universe is a grand reflection of our brains, or perhaps our brains are a microcosm of the universe. In essence, our brains and the universe share a strikingly similar pattern of intricate networks and connections. If you're intrigued by the dark matter mystery of the universe, you'd be amazed to know that our brains have their own version of dark matter. In the vast expanse of the cosmos, dark matter is a substance that we can't directly observe, yet its influence is undeniable. Comprising approximately 27% of the universe, it's the unseen force that holds galaxies together. Its existence is inferred from the gravitational pull it exerts, shaping the universe in ways we're still trying to understand. Now, think about our brains. Imagine that in our heads, there's a similar unseen force, a kind of dark matter that holds our neural galaxies together. This isn't a science fiction concept. These are the glial cells, often overshadowed by the flashier neurons, yet they make up about 90% of our brain cells. For a long time, these glial cells were thought to be mere support cells, the glue of the brain. But much like the dark matter in the universe, we're starting to understand that they play a far more critical role than we ever imagined. Glial cells are not just the scaffolding of our brain. They're active participants in brain function. They help form the structure of the brain, provide nutrients to neurons, and even regulate communication between these neurons. They're involved in everything from learning and memory to neurological disorders. Yet despite their importance, they're still heavily understudied. Much like the universe's dark matter, we know they're there. We're starting to grasp their importance, but their full potential is still a mystery. We've only just scratched the surface of understanding these unsung heroes of our brain. So, when you gaze up at the night sky and ponder the mysteries of dark matter, remember that a similar enigma lies within your own head. The glial cells, the dark matter of our brains, silently shaping and influencing our neural cosmos in ways we are yet to fully comprehend. Like the universe, our brains also contain dark matter whose full potential we're still trying to comprehend. Both the universe and our brains are powerhouses of energy. Let's delve into this amazing parallel. Let's start with a number that is almost unimaginable. The total energy of the universe is around 4, followed by 69 zeros joules. That's a staggering amount of energy, right? Now let's bring it closer to home. The human brain, this 3-pound marvel inside our skulls, uses approximately 20 watts of power when we're just sitting and thinking. That's about the same energy used by a dim light bulb. Now you might be thinking, how can we even compare these two vastly different energy scales? But here's where it gets fascinating. Despite the grand scale difference, both the universe and our brains share a common trait. They are constantly converting and using energy. The universe, with its vast expanse of galaxies, stars, and cosmic phenomena, is in a constant state of energy conversion. Stars, for instance, convert hydrogen into helium through nuclear fusion, releasing a tremendous amount of energy in the process. This energy powers the stars and eventually reaches us in the form of light and heat. On the other hand, our brain, though not involved in nuclear fusion, is a master of energy conversion in its own right. It converts the chemical energy from our food into electrical energy, which powers our thoughts, memories, and behaviors. Every time we learn something new, make a memory, or even dream, our brain is at work, converting energy to make it happen. In both cases, the energy is not created or destroyed, but merely transformed from one form to another, following the fundamental law of physics, the conservation of energy. So despite the vast difference in scale, the universe and our brains are not so different after all. Both are dynamic powerhouses, continually converting and using energy, driving the cosmic dance of stars and the intricate ballet of our thoughts. Even though the energy scales differ greatly, both the universe and our brains are powerhouses, constantly converting and using energy. As we journey from the vast cosmos to the intricate network of neurons, it's clear, the universe is indeed in our brains. We've traversed through the mind-boggling numbers, the billions of galaxies in the universe mirroring the billions of neurons in our brains. We've roamed the cosmic web of neurons, echoing the structure of the universe itself. We've delved into the enigma of dark matter, a mystery both in the cosmos and our cerebral corridors. We've marveled at the energy parallels, the universe's power and our brain's energy expenditure, revealing an uncanny resemblance. All these astonishing similarities point to one conclusion. The universe isn't just out there, it's also within us, a reflection in our cerebral mirror. So the next time you gaze up at the night sky, remember you're not just looking at the universe, you're also looking